I think the experience so far is great, although we have some hiccups here and there. And I'm actually now talking from the Lego room of my son, which I converted into my office now for the pandemic. So I'm Michael Staib. I'm a Microsoft MVP, and I'm the author of the Hot Chocolate GraphQL library. And today I want to explore with you what GraphQL is and how we can make .NET better with it. So when I go to conferences and user groups, a lot of .NET developers still don't know what GraphQL is or what you can do with it. And there's also a lot of misunderstanding what GraphQL actually can do for you. So GraphQL actually was developed by Facebook in 2012. And they did that because when they started developing mobile applications, I don't know if any of you remember that, it was actually quite a disaster for them because they tried basically to use standard internet technology like HTML and REST to build their mobile applications. And when these came out, they earned a lot of criticism that they are too slow, they eat through your battery life, and on top of that, they used a lot lose a lot up of your data plans. So Facebook back then sat down with their engineers and they looked into the problem and they discovered that their application actually fetched a ton of data just by starting up. So they basically opened up hundreds of connections just by opening the application. So in order to explore that a little bit, what actually went wrong with the application, I've prepared a little demo because I like a lot of hands-on in presentations, so start with the demo. So what I want to do with you is basically solve a little algorithm here. What we want to do is basically fetching data from a REST API that is called the Star Wars API. And our little algorithm that we want to create with the Star Wars API is to fetch all the characters that appeared alongside Luke Skywalker in movies. That's an easy enough task. We just want to build up a list of names with all the characters that appeared in Star Wars movies alongside Luke Skywalker. And there is an API that is called swappy.co, or I'm using now a different clone of it, which basically gives us all the data. And in REST, data is organized in resources. So REST services typically expose like resources through endpoints, and they are easy explorable. On this service, we have, for instance, a people endpoint that exposes all the characters of Star Wars that appeared in any movie. We have other resources like the film resource and species resource, starship resource, and all that that is associated with Star Wars. And it's kind of, if we want to build our algorithm that fetches all the characters that appeared together with Luke Skywalker's, we might want to start and fetch maybe first the people's endpoint and look what data it has. So if we fetch the people's list here, then we would get, as we expect, maybe a list of characters. And these, if we look into the data, it's easy understandable because it's just JSON. For instance, we have here a Luke Skywalker character, and the next is maybe a 3CPO character, and so on, all the characters. And we also can see that we down here have attribute called URL, which is pointing to the reference to this specific object. So if you would follow that along, we would get the single Luke Skywalker object. And it's, again, easy to explore. If we look for the data that we need for our algorithm, we might see, okay, there's a name in the character object, which is good because we want to build a list of names. And then I can see here there is an array of films. And when I think about it, we just need to grab these items that are in the array of films. And if we look at this, it's again references pointing to the actual movie objects there. I could, again, follow these along and get basically the specific movie objects. And I again see there's lots of data, like there's a title of the movie, there is an opening crawl describing the movie, and also we can see there is a characters array, again with lots of references pointing to the characters. So it's easy now to guess how we would need to build our algorithm to fetch that data. So let's head over to Visual Studio Code, where I prepared already this algorithm. And let me scroll to the REST algorithm. And let me walk you through that. It's only a JavaScript I will show today. The other code is all nice.NET. So basically, the first thing that we do is we're going to fetch Luke. We're going to fetch the character 1. And then we basically start iterating over the movies array. And then we're going to fetch each of those movies. And then we're going to iterate over each of those movie objects characters array and fetch each of the characters, because these are actually the characters that we want. And then we just extract from the payload the name. And if we look at this already, we already can see that this might be not the best approach to fetching data, because we will have a lot of requests that are dependent on each other. So I have the program already here set up. Because my internet is not so good, let me get my prepared version here. This one. And I already ran this test in the morning. And I would actually do it live, but with my network issues, I refer to that fixed version here. So what we can see basically is that our algorithm ran for 13 seconds. And it took 62 requests, and we can already see that we have kind of a data waterfall where we have the initial request, and then our movie request waited for this one, and then issued more requests. And this is exactly what happened with the Facebook app. Basically, they fetched their timeline, and then had to fetch the comments, had to fetch other related data, and it took forever to get all the data displayed. And the another thing here is you also fetch a lot of data that you don't need. You can see there are like 577 bytes here, 780 bytes there, and actually I just want the name. So let's have a peek how we would get at such a problem with GraphQL. So I have another program prepared here. I basically rewrote that. I just rewrote the GraphQL server on top of the REST service behind that. And that is basically exposing this Star Wars API in a GraphQL form. Okay, so this tool is called Banana Cake Pop. It is built by our project, and it is an awesome way to explore GraphQL APIs. So I put in my GraphQL service URL here, and when I click here on the left-hand side on the book icon, I can see that there is a query root type, and I have a field called character that is basically the data that I can query for. So I can already look at that. So if I want to explore that more, I can click on that character field here, and I can see, okay, that returns a character, and the character has like a couple of fields here, and I can see this character exposes a movie. When I click on that, I can see, oh, it returns a movie object. That's different than with the REST approach, where I got this references to the movie. Here I get the actual object. And I again can explore my movie object here and see that I can call the characters. So basically like in REST. So let's go back to my query pane. And so in this GraphQL IDE, on the left-hand side, I can write my query. On the right-hand side, I can get the result. So let's explore how we would write a GraphQL query. So in GraphQL, I would start with the keyword query, and then with curly braces. And then the tool will already help me along and offer me what I can do. So in this case, I can ask the character. The character needs an ID. And I already know from the REST endpoint that my ID is 1. And I actually can drill into that. I, for instance, can pick the name of the character, and maybe just let's execute that and see. Oh, awesome. I just get that back what I requested. So I asked for the character of Luke, and I get back the Luke Skywalker character there. Okay, let's explore that further. I can drill into the data with GraphQL. I can pick the movies, and I maybe ask for the title of the movie. And then I also can drill into the characters and ask for the name of the characters. Let's issue that request. Boom, I already have the data. It's super fast. And remember, behind that service is the actual REST service that we used earlier. But it's much faster interaction here. And I can already see I quite have what I want. But actually, for our algorithm, let's get rid of these two. And basically, I'm done. So compare this to the algorithm that we had to write for the REST service. And here I just wrote the GraphQL query and sent it over HTTP to my GraphQL server and got exactly the data back that I need. No aggregation on the client. The aggregation is done in the cloud where we have unlimited bandwidth and where we are close to our microservices. Okay, let's go back to our benchmark. I pre-ran this also. And when you look, the benchmark actually says 105 milliseconds to fetch these characters, but actually it was 47 milliseconds that it needed here because Chrome some kind needed to queue the request, and actually it only needed 47 milliseconds to fetch this data over GraphQL. Compare that to the 13 seconds at the same time that I needed to fetch that over REST. Okay, let's go back to our slides. Let's reflect a bit on that. So with GraphQL, I, the consumer of the API, are in the driver's seat. I define what data I want. I define the shape. I define how deep I want to drill into the graph. And the server will basically fill out that graph. You can maybe think of GraphQL when you get started with it. It is not like that, but you can think of it like an empty JSON graph that you send to the server, and the server fills that up. And that means request and response closely align, and that is by design and one of the big features. So we could also do dynamic requests with REST, right? We could create something like this Amazon Shop API that can do lots of things. But actually, with REST, it's more complicated. Because with REST, basically the consumer of the API or the front end or the backend developer have to closely work together. Because the front end developer might have a requirement, has a new device to support, needs a smaller or larger request that has more data or less data, or needs an optimized request. So he has to work to the backend developer and request it. The backend developer has to build that in, and there's a lot of back and forth, and often things go wrong in that. We have multiple iterations of trying to fix that service that we actually want to build, and there's a lot of frustration. So what is GraphQL actually? So GraphQL is a query language for your API, and runtime to execute on those queries. And in an ideal world, or that's actually how Facebook did it, you would put a very thin layer of GraphQL over your business layer. So you have with GraphQL a way to expose your business logic in a much better way, because the GraphQL type system knows things like interfaces, union types, objects, scalars, and you have a very rich type system that is enforced by the query engine. But GraphQL is very flexible, so you don't have to do that in that way. We can also put that over microservices, or you can put it over old SOAP infrastructure and basically create from those fragmented microservices one monolithic truth of source of truth from which you actually can pick the data like you need it. And the GraphQL query engine will aggregate the data from those different sources very efficiently with execution plans or data loader and stuff like that. So with GraphQL, we strive for this one single source of truth where we can pick the data from. It's some kind a fix for the microservice world, so that we still can interact with one endpoint that exposes our data. And this allows us to fetch everything in one request because we control the requests. We build the requests. And that basically fixes the N+1 problem for us on the client side, because we don't have overfetching. And overfetching is every time I had to consume some data from my REST service that I actually didn't need. For instance, the first initial Luke Skywalker object and the movies objects, I didn't need them really. I just needed to fetch them because there was a reference to another object. And that's also what underfetching is about. Every time I hit one of those references, those UIs that I needed to fetch some other data, that's basically underfetching, because I actually didn't want the reference, I wanted the object behind that. Okay. And GraphQL is built on a strong type system. And we will see that in a further demo what that really means, because the strong type system, I said we have interfaces, we have objects, that really secures me as a front-end developer and also me as a back-end developer, because I can put the data that we expose in a very strict type model. And GraphQL is real-time. And real-time is so simple with GraphQL, since you basically write a simple query and we can make that real-time. We will see that also. And all of this makes GraphQL very predictable to use. So what I've told you so far is basically that with GraphQL, we can give the clients or the front-end developers the power to ask exactly for what they want. I basically told you so far that we can basically drill into the data as we want. So there was a nice article on Medium about that when Airbnb introduced GraphQL. And basically the reaction from the backend developers was not so good in the beginning. But actually, GraphQL is a real opportunity for backend developers. Because we as backend developers are now able to describe our data in a much stronger way, with strong types. And we can define how you issue your requests. We can control what complexity a query can have. We can put in there things like persisted queries to make it very efficient to fetch your data. So GraphQL is actually really an opportunity. And if we look back at the history of Facebook, it was actually developed by backend engineers to solve backend problems. Okay, and GraphQL, if we look at how GraphQL works. So in GraphQL, we query data through root types. We learned already the first root type, which is called query. It's basically a side effect-free fetch of data. You could compare it to the get in REST. And side effect means that the server basically can optimize the data fetching so that it fetches most data in parallel to get the data faster. And then we have something that is called a mutation, and that is basically the write request. And mutations have side effects because they change data on our server. And it basically compares to the put, post, patch, and delete. I never knew what to choose of those, but in GraphQL, it's just a mutation. And then we have the subscription root type, which basically is our event system, our PubSub. It's our real-time data fetching. So this makes GraphQL really awesome to use because you have all the data capabilities that you need. You have the stateless data interaction with queries and mutation, and you have the stateful connection with GraphQL subscriptions. So let's head to my next demo to explore a bit what that actually means. So let me get to my console. and .NET Run project. And let's pick operations, Star Wars. So this is another Star Wars example. This server has a bit more operations. So let's just type in the local host .5000 GraphQL. We fetch that. Okay, our schema has already refreshed. I can see this is no longer valid. And we can see I have now much more. I have here my query types, and I have my mutation type, I have my subscription type. And if we would drill into those things, we can see, okay, the character type now actually is an interface. Oh, that is some kind of wrong. Let me just refetch that schema and get back into, yeah. Now my character return type is actually no longer object. It is an interface. It is implemented by Droid and human. That means I have a much richer data model now. So let's explore first how we can query, for instance, with interfaces. So we could ask for the character, or let's ask for the hero of a specific episode, maybe. Let's say Empire. And then we can fetch data. So that is simple. We did that before. It's Luke Skywalker. But since we have now interfaces, we can look at specific aspects of our character. So we could say, so if this object is a human, then give me, for instance, the home planet. So if we fetch that, we get this specific property of this specific object because now it's a human. But if we switch to a different fetch and fetch R2D2, we wouldn't get that property because now it's a droid. And we could do that by saying, okay, if it's a droid, I actually want the primary function of that droid. Awesome. So this is, you can already see that there is much more possible with data fetching in GraphQL. So because time is short, let's head to mutations. So mutation means we can change data. And I now have a mutation here that is called create review. And I am able to write reviews for certain episodes. So I could say I want to write a review and let me add some stars, maybe 5 stars, do a commentary, good movie, and then actually in GraphQL you don't have like mutations that return nothing. They always return something. Like I could reselect the data that I have written. In actual GraphQL implementations, you basically would requery all the objects that your mutation has affected. And that allows you to instantly update stores like Relay or in Apollo with the correct IDs that the server produced or stuff like that. So let's just execute that. Okay, awesome. It doesn't feel awesome because it just returned the data that we had. But bear with me a second. So let's create a new tab here. Because I said we have real-time data. And those real-time data is most often driven by mutations. So a real-time query would start, in this case, with subscription, with the keyword subscription. And I now have things like, oh, there on review, when there is a review, and a review is written for Empire Strikes Back for this episode, then actually I want the stars because I'm writing like a little application that aggregates now the stars for every given review for this episode. So I now execute that, and actually nothing happens because my GraphQL IDE now starts to listening for this query. It issues the query to the server, and the server will keep now a connection open with us and only sends us messages when we issue a request. So I put open the results tab here. And if we go now back and issue now requests here, you can see that my results tab on the other, my other tab with my real-time data already had 3 results here with Okay, with 5 stars. I could change that, and just to see that it's no fake, I put 3 in, and I get basically my last result, 3 stars back. So that's real time, and it feels the same way as if you would write a GraphQL query. Okay, let's get rid of that. Let's leave that open. Rid of this server, and then head back to our slides because I have a lot more demos. Okay, so we looked at what GraphQL is. Let's also look at what GraphQL is not. So GraphQL has nothing to do with the graph database query language. Often people think GraphQL is a graph database language for, I don't know. It has nothing to do with that. Initially, Facebook called GraphQL actually super graphs. That was their internal name. But I think with the name GraphQL, they really did a better choice, but they still are sometimes confused with that. And it's actually GraphQL is not bound to any specific data source. I said we can put it over our microservices, we can put it over SQL, we can put it over our API. So it is not bound to a specific data source. And it's not Facebook's version of OData. It's capable, it has so much more capabilities than OData and has a different mindset if you look at the design. And also GraphQL is not a good solution for binary streams. If you look at Netflix, Netflix is using GraphQL, but they're not using GraphQL to stream movies. Because if we looked at GraphQL so far, it's very good for data. We're very good where you have data with relations, where you drill in and stuff like that. And an important aspect is also that GraphQL is not bound to HTTP. GraphQL is actually transport agnostic. And our project is releasing GraphQL on gRPC in August. So you can put it actually on anything. We already support it on WebSockets or on SignalR, on HTTP, and you could put it on any transport channel. And GraphQL is also not limited to JavaScript. And if you look at the history of GraphQL, you actually see that it was designed to improve data fetching for mobile applications that maybe run on a bad network. And actually, the first GraphQL server was written in PHP by Facebook, because back in the days, they used mostly PHP. Okay, so let's have another demo, and let's have a look how we would use GraphQL in .NET. And now we will do actual coding. Okay. So I will use Visual Studio Code. Let's open that up. Okay, I'll actually make that a little bit smaller. And so this project here is a simple empty ASP.NET Core project. It basically is a .NET Core 3.0 project in this instance. It has nullable reference types on. Just keep that in mind. And it has our hot chocolate ASP.NET Core package in there. But apart from that, we have an empty ASP.NET Core, empty startup here, and there's nothing in there. So how would we go about writing a GraphQL server? We saw that it's about root types. So we have maybe types like query type. So we could start writing a class query. Okay, but what now? We need something to return. Let's maybe create a character object. So we create another class called character. Scroll it a bit up. And properties. I have already prepared some properties. Maybe we have 2 properties here, an ID, an ID property and a name property. And then we might just go here in our query class and say, okay, we are returning a character. And the character is maybe called getCharacter. And we're just doing a new character. And then maybe run it. But let's go a bit further. Let's maybe say we have a string here. The string is name, and it has a default, maybe Luke. And actually, let's feed in the name here to Luke. Okay. So how do we get this to become GraphQL? So what we could do is, or what we have to do is, we add a schema to our services with the extension method at GraphQL, and there is something called in Hot Chocolate that is the schema builder. You basically say schema builder new add query type, that is our root type, and then say add our query here. And then we actually are done. Our schema is ready. It should be a valid schema. But we need one more thing. We need something to execute on our GraphQL schema. And that is a ASP.NET Core middleware called use GraphQL, and that actually does the magic. Let's do a .NET Watch and Run. Head over to our GraphQL IDE. We fetch actually the schema. That's not right. Okay, and we have our root type here. It has actually it has a field character, and we can expand this, and then we can see it has an argument name, and it also correctly inferred the default value that we passed in, that is Luke. That's awesome. And it also, because we are using nullable reference types, it also detected, okay, string, this exclamation mark means this string actually is a non-nullable type. So if I go now back into my query here, I can say, give me that character. Actually, I put something else in. Let's fetch that name. Boom, and I'm done. It's so easy to create a GraphQL endpoint. But there's actually more to that. And you can do much more complex GraphQL services. Like in many implementations, you have to use like type type classes to use some kind of a fluent API to tell the GraphQL engine how the type is structured. You can do that with Hot Chocolate as well, because it's a useful thing if you don't own the library, or if your character class, for instance, lives in a different library and you can't change it, and it maybe doesn't use non-nullable reference types, then we could use a type class like that, and we could tell that field, for instance, ID, it should actually be the type ID type. And then we could basically tell our root type, actually this type now is the GraphQL type of character type. Sorry. Which now would tell the engine from this, what you return here is actually a character type, and take your type information from here. You could also have a character type class, a type class for query, and put that also in the schema builder. We will figure that out. Hot Chocolate is very good in inferring your types. Okay, let's move on. Let's close that. Get back to our slides. So awesome! We did our first GraphQL server in under 2 minutes in .NET, and you saw it is quite easy to build that. So, but these hello world examples are often oversimplistic. I know. Most of the times people ask us, I use entity framework. I have an entity model. How can we use that with Hot Chocolate in GraphQL? Make my old objects work with the new world. Okay, let's head to our next demo. I think code is how we think. So let's have a look at more code. So I go to this next demo, and I took this demo. It's not anymore Star Wars. It's now Contoso University, because I went to the Microsoft docs, and they actually have an example to use Entity Framework with ASP.NET Core. And there they basically have this school context. It's called the Contoso University. And they have like entities like this students. And basically our student has a lot of enrollments to courses at the university. And the enrollment basically exposes courses for students. It's basically an end-to-end relationship. But also the environment has a property grade, which is a grade for this course that was reached. And the courses then again have like the credits that you would earn as a student at that course. So how can we spin a GraphQL server around this? So again, it's a standard ASP.NET Core application. I just did a bit logging here, an extra logging, because you will see why in a second. And our startup is a bit more prepared because I now have a DB context. I already set up the schema here. There's actually nothing in the schema yet. It's just an empty schema builder. And I also set up the GraphQL middleware, and I'm also initializing the database when we start. So a very simple setup. So as we did before, we would probably start by writing our class query, because that is our root type, with which we would fetch the data. And we would basically start by maybe saying, okay, we want to first fetch the students. Let's write a function that fetches these students. So we would write a queryable here, and that maybe is a queryable of student. And then we would call this get students maybe. And then we need something. And in GraphQL, everything is resolver specific. Because I can use fields or use them not, it's good for the execution engine to actually know what we are using. So we could use like a service in here. And the service actually for us is the school context. So we're using the school context. And then we can take this school context, which is a DB context, and basically fetch from that the students. Or let's just return the students here. And then we grab this query type and basically add that to our schema builder up here. Say add query type, query. And maybe just run this thing. .NET run, because we're gonna change it further. Okay. So this thing is getting up. Wait a second. Okay, we can see already SQL because it's checking if our data is there. And let's go here. It's the same port. So our GraphQL ID is shortly messed up. Okay, so I can already see I have the students there. Awesome. But when I look closer, I can already see, oh, I have the enrollments there. And if I drill in, I can already see I have the courses there. Okay, so the schema builder actually inferred automatically our full object model. And if I'm starting to query that, I actually can query maybe the student's last name. Maybe I can take the enrollments here. And let's get the course title, and maybe let's also get the grade. Okay, awesome. Let's fire that up. Okay, disappointment. I get the name, but I don't get the enrollment. That's because our query execution engine actually does not know how it works yet. So we can head back to our query class here. And there's something in GraphQL that is called, in our GraphQL implementation, that is called field middleware. So we can tell our GraphQL engine that it should use maybe selections. And selections basically is a projection middleware that knows now, it understands querybles, and it understands how to navigate data. Okay, so let's go back in here, fire that up, and boom, I get the data. I get all the data. The GraphQL query engine now knows that this is a queryable and that it can rewrite expression trees on that query. And if we look at our output here, we can see that it rewrote basically the incoming GraphQL into SQL. And we can do actually more because we have more middleware. So we could say use filtering. And we could say maybe use sorting. And because it's actually not safe to expose the API like this, we also want to use paging. Okay, it's recompiling. Starting.